Okay, so here we're going to start experimenting with capacitors now. I have this 100 microfarad capacitor right here in line with 3.3K resistor and a 10K resistor. Now we're going to observe what happens when I press the switch. Essentially, the charge is going to go straight to the capacitor, charge it up, lighting the LED, and when I let go of the switch, the capacitor is going to discharge and the LED is going to slowly turn off. So, as we see, it slowly lit up. The capacitor is now charged, and when I let go of the switch, it's going to slowly discharge, and the LED will go dark. Now, if I was to replace this 3.3K resistor with just a 1K resistor, to see what happens when we change the resistance that the current has to go through. We notice that it charged up much quicker and discharged much quicker because there's now less resistance for the current to travel through. Now, if I was to replace this 100 microfarad capacitor with just a 10 microfarad capacitor, if I could get this thing going now. Awesome. Okay, so I'm gonna keep the 1K resistor in there. We're just gonna see how it differentiates from the last time. So notice when I press the button, it lights up almost instantaneously. When I let go, it turns off almost instantaneously. Now, because the capacitor has a smaller capacitance rating, there is less room for the current to build up, and therefore, when there's less current built up, and it discharges less current, and needs less current to get completely charged. So that's going to take the total time it needs for it to charge and discharge, and therefore the LED, we will notice, is going to light up and fade much quicker.